Good day, everyone. In this video, we're going to have the part number 2 of our lesson about proving right triangles using distance formula. In this video, we're going to have the chance to apply the distance formula together with the horizontal distance formula and vertical distance, and of course, the Pythagorean theorem. Without further ado, let's solve the problem. Prove that point C with point 0, 1, point A 3, 1, and point T 3, 4 form an isosceles right triangle. Let's proceed on the first part, which is the plotting of the points. Let's plot C, that is 0, 1. We have A with 3, 1, and point T at 3, 4. And based on our illustration, we could form a triangle. Now, in order for us to conclude whether it is an isosceles right triangle, we should obtain first the following distances or the sides of the formed triangle. We're going to identify the distance between CA or side CA, side AT, of course, and the last side, which is side TC. Okay, let's solve number 1. To obtain the side CA, we're going to use the horizontal distance formula, and that is the absolute value of x of 2 minus x of 1. Because if we're going to observe point C and point A, they are horizontal points. Let's solve the following given. C is located at 0, 1, and A is located at 2, 1. Let's substitute the givens. We're just going to focus at 0 and 3. Where 0 came from point C and 3 came from point A, where 3 is your x of 2 and 0 as your x of 1. Let's have the substitution process. So CA will be equal to the absolute value between the difference of 3 and 0. 3 minus 0 is equal to 3, so therefore the distance between point C and point A is equal to 3, or simply side CA is equal to 3. Now, let's proceed to number 2. This time, we're going to look for the distance between point A and point T. Based on our observation, point A and point T are points that are vertically aligned. So therefore, we're going to use the vertical distance formula. And that is the absolute value of y sub 2 minus y sub 1. Let's set the following given. Point A is located at 3, 1, and point T is located at 3, 4. We're going to focus only on its y values, where 4 is your y sub 2 that came from point P, and 1 as your y sub 1 that comes from point A. Let's have the substitution process. So therefore, we're going to have 80 equals the absolute value of 4 minus 1. 4 minus 1 is equal to 3, and for 80, excuse me, our side 80 has a length of 3 units, or simply 3. And let's have number 3. Number 3 is we're going to get the distance between point P and C, or the length of PC. In this case, it is not horizontal nor vertical, so therefore we're going to use the distance formula, which is the quantity, or I mean the square root of the sum between the quantity of x sub 2 minus x sub 1 squared and the quantity of y sub 2 minus y sub 1 squared. Let's split the following given. Points T and point C. T and C. Point T located at 3, 4 and point C located at 0, 1. Where your x sub 2 is 0, that comes from point C, and 3 as your x sub 1 that comes from point T. 1 as your y sub 2 that comes from point C, and 4 as your y sub 2 that comes from point T. Let's have the substitution. And it will go just like this. PC is equal to the square root of the quantity 0 minus 3 squared plus the quantity of 1 minus 4 squared. Let's simplify it further by getting their differences, and we're going to obtain This equals the square root of the quantity, negative 3 that comes from 0 minus 3, then put squared, plus 1 minus 4 will result into negative 3, so let's have that, then squared. Let's squared both the answers, and we're going to have this equals the square root of 9 plus 9, because negative 3 squared is 9, and negative 3 squared is also 9. TC will become square root of 18. That came from the sum of 9 and 9. So therefore, the measure of TC is equal to the square root of 18. This time, we already have the following lengths of our side. CA is equal to 3, AD is equal to 3, and side PC is equal to the square root of 8. Now, in order for us to conclude whether it is an isosceles right triangle, we're going to apply the Pythagorean theorem. It is stated that c squared is equal to a squared plus b squared. So therefore, if we're going before we proceed on our solution, based on our observation, of course, square root of 18 is the hypotenuse at the longest side of our triangle. And if we're going to observe it, both CA or side CA and side AT has the same measurement of 3. Okay, so let's proceed. So C will be equal to square root of 18, and sides A and B will be equal to 3. So let's proceed to substitution. Therefore, we're going to have the square root of 18 squared equals 3 squared plus 3 squared. The square root of 18 squared will become 18, and the right side of the equation will become 9 plus 9, because 3 squared is equal to 9, plus 3 squared is equal to also 9. 18 will be equal to 18, and that is a check. Okay, so therefore we can say that the given triangle is a right triangle. And given that it has two legs with the same measurement, such as CA is congruent to 80, so therefore we conclude that CAT, or the triangle CAT, is an isosceles right triangle. And that is all. Okay, so that is all for this video. Thank you for listening, and see you on the next video.